Hello Year 10. We're starting a new module on ratio for the next week or two. And we're going to start today with simplifying ratios, which you will have done before, so this is mostly revision, but there are a few harder examples that you need to be aware of. So I'm going to take you through some examples, and then I'm going to set you some independent work to do. Example number 1, simplify the ratio 9 to 21. So what's really important for us with ratio is to develop being able to use proportion boxes, which we have seen before when we did percentages, because these are really, really useful for harder questions. So it's important we develop that technique now when we're doing slightly more straightforward tasks, and then we'll be more familiar with them when we move on to harder questions. So I'd really like you to use these proportion grids. So our ratio that we're trying to simplify is in the top of the proportion grid here, 9 to 21. And what I'm looking for is the highest common factor, the biggest number that will divide into both 9 and 21, which in this case is 3. So I'm going to divide both sides by 3, and that will give me 3 on the left-hand side and 7 on the right-hand side. So my answer is 3 to 7. Now, ideally, you want to be looking for the highest common factor, but if you don't spot what that is and you just divide by a factor, then it might mean you need to do this in 2 stages. So trying to find the highest common factor is going to be more efficient, but you can also simplify by dividing and dividing again. Right, next example, simplify the ratio 2.4 to 6. So you might be expected to simplify ratios where you don't have integers, where you have decimals. And the technique is exactly the same. I've got my proportion grid, and I am looking still for a number that will divide into both 2.4 and 6. And I'm actually going to use my skills from times tables to be able to think about this, because what I'm actually thinking about is 24 and 60. So I'm trying to think of the biggest number I can that will divide into 24 and 60. And if I'm really, really good with my times tables, I'll know that the answer to that is 12. So I can then work backwards and say, well, if 12 divides into 24 and 60, then 1.2 is going to divide into 2.4 and 6. So I'm going to divide by 1.2. And that will give me 2 on the left-hand side and 5 on the right-hand side. So when I simplify, I am looking for integer numbers in my answer. I can't leave decimals or fractions in there. And so my answer is going to be 2 to 5. Next example, you might need to work with 3-part ratios. So here I've got a 3-part ratio, 12 to 18 to 24. There are 3 parts to it, but the principle is exactly the same. So I'm drawing now a slightly bigger proportion box with the ratio along the top. And again, I am looking for my highest common factor. And here, hopefully you've spotted highest common factor is 6. So I'm going to divide all 3 parts of my ratio by 6 so that I end up with 2, 3, and 4. And so my answer is 2 to 3 to 4. Right, final example. This is an example where we have units included, and the units are not the same for all parts of the ratio. So on the left-hand side, I've got pounds, but on the right-hand side, I've got pence. So the first thing I've got to do before I can simplify this is make the units consistent. And I can do this either way. I could convert this into pence, and equally I could convert this into pounds. But if I convert that into pounds, it's going to give me half of a pound, and that's going to make it maybe slightly more awkward. So what I've decided to do here is convert £3.50 into pence. And now again, I am looking for the highest common factor. You might do this differently. You might decide, well, I'm going to divide by 10 first of all, and then you would have to divide again. But as I said before, the most efficient way to do this is to look for the highest common factor, and that is 50. So 50 is going to go into 350 7 times, and of course it's going to go into 50 once. So my answer is going to be 7 to 1. So what you've got to remember is your simplified ratios have always got to be integers, and also that you've got to change your ratio to have consistent units if your units are different throughout your ratio. Okay, so here is your task for today. What you're going to need to do is to pause the video so that you can then work through these in your book. I want you to show me working so that I can see how you've done this. You've got some 3-part ratios in part C here, and you've also got a 4-part ratio. So again, that's exactly the same idea. You've just got 4 bits to divide. And then in part D, you've got units being introduced, but here the units are the same. So really you don't need to do anything to change those. And then in part E, you've got units, but you start to get questions where the units are different on either side of the ratio. So you have to make them consistent first of all. So what I'm going to ask you to do is pause the video, do this in your maths books, and then when you submit your task when you submit your assignment on Teams, I'd like you to take a photo of your work and upload that when you submit your task. The easiest way to do that is if you've got Teams on your mobile phone or on your tablet, then when you upload, you can take a photo on that device and then upload from this device. So that's really nice and easy. If you're doing Teams on a laptop, you might need to take a photo and email it to yourself and then save it and upload then from your laptop. But I'm asking you to actually upload a photo of your work so that I can actually see what you've been up to and have a better idea of how you're getting on. And I'll give you the answers in these in tomorrow's lesson so that you can mark your work and see how you got on. But that's it for now. So pause the video and have a go at these questions.